I really hope today's lesson is online. Blue,
Welcome.
turn on Learning Lab.
A's online initiating.
Connect today's lesson.
Get your education set. Connecting.
Alright, so we're going to get straight into question 1. Write the numeral for 48 ones and 2 hundredths. Okay, so we're dealing with a nice simple place value question, and once we're dealing with ones, that's an easy thing to achieve. Writing 48 ones is just 48. Alright, really, literally, it will be 4 tens and 8 ones, but to trick you a little bit, we have 48 ones. Now for the 2 hundredths part of the question, once we have THS in our number name, the place values come after the decimal point. So from the decimal point we have two sides. We have the right hand side and we have the left hand side. The left hand side we are very familiar with. We're learning about them since infants. We have the ones, tens, hundreds, thousands, and so forth. But we have already dealt with those numbers. We already have 48 ones. What we have to deal with is 2 hundredths. So immediately after the decimal point on the right hand side, we have tenths ending in THS. We have hundredths, which is what we are dealing with for this question, and it also ends in THS. So it's similar to the left hand side, but it doesn't start with ones, it starts with tens, and the name ends in THS. So the 2 hundredths that we have to represent for this number will come in this position, and they did not mention any tenths, so we're going to put a 0 in that position. So the full answer will be 48.02. Complete. Number 2. Round off 9,506 to the nearest thousand. So for rounding off, I always go to a separation with a line. Finding the place value they want you to round off to, the nearest thousand up to the 9. I'm going to draw a line to separate the numbers that will change to zeros from the numbers that we have to focus on a little bit. So once the number coming immediately after on the right hand side is 5 or more, we will add 1 to the number before the line. If it is less than 5, we would keep the number the same. That's before the line. So here 5, so we're going to add 1 to the 9, giving us 10. And the line helps us to put in zeros for all the numbers coming after it. And our final answer for number 2 is 10,000. Number 3. Complete the number statement below. We have a funny symbol. It says the square root of 144 multiplied by 3 squared is equal to 6 multiplied by empty box. So if we have to actually figure out what number goes into the box, we need to get the same value on both the left hand side and the right hand side. So we need to work out what's the value of the left hand side, because we have all the information for that side, to know what number to put in the box on the right hand side. So here we're going to do the square root of 144, and square root and squared or raised to the power of 2 are actually opposites. So when we want the square root of a number, we want to know what number raised to the power of 2 will give us 144. So the square root of 144 is one of the easy ones we're supposed to know, 12, because 12 times 12 is 144. 3 raised to the power of 2, of course, is 3 times 3, which is 9. So you have 12 times 9, 12 nines are 108. So the left hand side value is 108, so therefore the right hand side's value should also be 108. So how do we figure out what number goes in the box? We need to take 108 and it will be 6 multiplied by what number gives 108? Well, that's simple. We're going to just divide to the opposite of multiplication to figure out the missing number. So it becomes 108. We're going to divide that by 6. Long division, this will be a nice quick one. 6 into 1, cannot. So I bring in the 0. 6 into 10 is 1. Multiply. 6 ones are 6. We want to see what remainder we have here. We have 4. Bring down the 8 to meet up with the 4. 6 into 48 is 8. 6 8s are 48. We have no more remainder. So our long division comes to an end. So the answer that's supposed to go in this box would be 18. Yeah, nice quick maths. Next question, number 4. How many more squares must be shaded so that 2/5 of the shape is shaded? Alright, so we're going to do a check to see what's the total squares first. And we can do that easily by checking how many going across, how many coming down, and multiplying them. So you have 1, 2, 3, 4, 5 squares going across, and 1, 2, 3, 4, 5 squares coming down. So that's a total of 5 times 5. Once we multiply them, we'll get the total amount of squares, which is 25. And how many squares are shaded? And that's easy. We can just visually see. Check it in our minds. That's 4 squares shaded. But they want 2/5 of the entire shape to be shaded. So for us to calculate how much is 2/5, the fraction must be multiplied by the total amount of squares. We want to know how many squares does 2/5 represent. So we're going to multiply 2/5 by 25 over 1. When we multiply in fractions, we can reduce if you can and multiply afterwards. We can only reduce in an up and down fashion, so we're going to take the 5 and the 25 to reduce them smaller by dividing both of them by 5. So 5 into 5 is 1, 5 into 25 is 5. Once nothing else could reduce, we multiply going across on top. 2 times 5 is 10 over 1. Times 1 below, we get 1. So 2/5 of the shape shaded should be 10 squares shaded. In total, we only have 4, so we're going to take away to see how many more need to be shaded. How many more indicates as a keyword, key phrase for subtraction. So we're going to take away and we get 6 squares. And that's going to be our final answer. Alright, so that was a nice quick question on fractions. Moving right along, we're looking at money. Brad bought a pen for $11.50 and a highlighter. He spent $22.25 altogether. How much did the highlighter cost? So we want the difference between the total cost, which was $22.25, and the cost for the pen. Because if $11.50 was the cost of the pen, the extra money that he spent would be the cost of the highlighter. So we're going to calculate that extra money by subtracting the two numbers. And once you line up a decimal point, most important, lining up a decimal point in the number on top and below, you'll be able to get a simple working. I just want to make sure my numbers are lined up. So we're going to start to take away 5, take away nothing. You still have 5 if you take away nothing. 2 cannot take away 5. So we're going to borrow from this 2 on this side, leaving 1 there. And this 2 becomes 12. 12 take away 5, that is 7. 1 take away 1, that's 0. Make sure and have your point in your answer. And 2 take away 1 is 1. So the cost of the highlighter was $10.75. Alright, next question. Calculate the sum of 4 3/4 and 7.5. Alright, so there are two ways we can do this question. One of the things that will be the same in both ways is that we'll have to add, because the word sum means addition. So we're going to be adding these two numbers, but they can either both be in decimals or they can both be in fraction format. I think the decimals are a little easier to add. We just added decimals on top. So we're going to keep the 7.5 as a decimal, and we have to change 4 3/4 into a decimal. But the good thing is the 4 will remain the same. This whole number 4 is the whole number that comes on the left hand side of the decimal point, and the 3/4 part of it is what we actually have to change into a decimal. So to change 3/4 into a decimal, we're going to do as the fraction says, 3 being divided by 4. That's actually what's taking place. 3 on top is being divided by the 4, and we're going to add a decimal point with some zeros to get a complete set of numbers to work with. And we start dividing like normal. 4 into 3 cannot, so you put a 0. Immediately after the 3 is the decimal point, so you put the decimal point in your answer as well, and then you bring the 0 next to the 3 together. So 4 into 30 is 7. 7 4s are 28. We're going to subtract that to see what remainder we have, and we're going to get a remainder of 2. And then we bring down the 0 to meet the 2 here, and we get 4 into 20, which is 5. 5 4s are 20. Subtract, that's actually a 0. We have no more remainder. So 3/4 as a decimal is 0.75. is actually one of the fractions that we can learn and memorize because it's not too hard to remember. So now to add this up, once again we have to just make sure our numbers line up, our decimal point that is line up. So I put my decimal points in place first. If you want, 7.5 goes on top, 4 point, the number right after the point is the 7, so that goes under the 5, and we write the 5 next to the 7 there. We're going to be adding. If there are any empty spaces in either number, you're going to put a 0 to fill the space, and then you add 0 plus 5, that'll be 5. 5 plus 7, that's 12. Bring in the 2. 7 plus 4 is 11. 11 plus 1 is 12. So you get $12 and 12.25. Sorry, we're not dealing with money. So it's just 12.25. They didn't say if to put the answer as a decimal or if to put the answer as a fraction. So you can choose how you want to work it and how you want to write your final answer. Okay, number 7, another money question. A cupcake sale generated $700 on Saturday and $1,400 on Sunday. What fraction of the total money was made on Sunday? Okay, so we're trying to create a fraction, and they told us that $700 was for Saturday and $1,400 was for Sunday. So fractions are always written out of a total or over a total. So we have to first figure out, well, what's the total amount of money, and we're just going to add up Saturday's money with Sunday's money. 7 plus 4 is 11, and we're going to add this 1 to the 1 up here. That's supposed to be a 2, so that'll be 2,100 in total. So that's going to be the denominator in our fraction, because that's the total. And then we want the fraction for Sunday. So Sunday's money is 1,400. So our fraction is now 1,400 over 2,100. And then we reduce. You can only reduce fractions in up and down fashion. So we're going to start shortcut, crossing off some zeros. We're really dividing by 100 there. And then these numbers should look familiar. We have multiples of 7. So we're dividing both 14 and 21 by 7. 7 into 14 is 2. 7 into 21 is 3. So the fraction that we remain with, nothing else could reduce, is 2 over 3. So 2/3 of the money was made on Sunday, which is pretty good. Next question, number 8. $460 is increased by 30%. What is the new amount? Many different ways to work this question. We are going to just do 30% of 460, and we use the 30% in fraction format because a percent and a fraction are the same, and we're going to multiply it by $460. We want to see how much money we need to increase this by, and we're going to start to reduce by eliminating these zeros. So we cross off a 0 in 100, cross off the 0 in 460, cross off the 0 in the 10 remaining underneath, cross off the 0 in the 30 on top. Nothing else could reduce or cross off, so we have 3 multiplied by 46, which we can do easily right here. Oops, don't need a line. 46 multiplied by 3, 6 3s are 18. 3 4s are 12 plus 1 is 13. So we have 138. This is how much we want 460 to increase by. So the new amount, we're going to increase 460 by 138 by simply adding. Alright, so we're going to do 460. Please try and show you're working, because you want to get all the marks possible. 0 plus 8 is 8, 6 plus 3 is 9, 4 plus 1 is 5. So the new amount, if we increase $460 by 30%, you'll have $598.00. Make sure and write the complete number value for money, including cents. Alright, last 2 questions for today. Calculate 1,204 divided by 7. So we're going to do long division again. Long division isn't hard, it's just a little long. So we're going to do 7 into 1, cannot. 7 into 12 is 1. 7 times 1 is 7. You're checking to see the remainder, which should be 5. Bring down the 0 to meet the 5. 7 into 50 is 7. 7 sevens are 49. We subtract. See our remainder of 1. Bring down the 4. To meet the 1, 7 into 14 is 2. 7 twos are 14. 14 subtract 14. Our remainder is 0. So the answer, nice, quick and simple, is 172. And last but not least, number 10 for today, complete the number pattern. 36, 25, 9, 4, 1. So we can check to see how the numbers are increasing or decreasing by. Here we have decreasing values, and if we start off with the 36, we realize if we subtract 11 we get 25, but we don't have much information to see anything coming after that. From here we'll subtract 5, from here we'll subtract 3, so 9 take away 5 is 4, 4 take away 3 is 1. So the pattern in terms of the decreasing values of numbers would not necessarily appear easily here. These numbers, we need to recognize them for what they are. Special numbers, they are called square numbers, and those square numbers are 1 raised to the power of 2, 2 raised to the power of 2, 3 raised to the power of 2, 4 raised to the power of 2, 5 raised to the power of 2, 6 raised to the power of 2. Right? This is 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, 4 times 4, 16, 5 times 5, 25, 6 times 6, 36. These are the numbers we need to memorize because this pattern comes up all the time, and the number that we do not have in the pattern here is the trusty 4 squared, which is 16. All the other numbers are there: 1, 4, 9, 25, and 36 are all there. So the only number missing is 16. Alright, so that's it for today. Numbers 1 to 10. Thanks for joining the Learning Lab.
Hey Blue. Make sure to like this one and share to my favorites.
Already done, sir.
Great, thanks.
No problem.
Remind me to log in tomorrow again.
Reminder is set.
Sign out, Learning Lab.
A's online disconnected.
I'm out. See you later.
See you when you get back, sir. Remember to subscribe. Thanks for watching.